and cybersecurity.
Okay. Oh,
Like, write about one of these. How was it? It was in the quiz section, but it has not. Oh my God. It's really, is that there's not really a very long answer. It's before. My brain is so big, I forgot about something so small. My brain's so huge.
Okay, so let's start our operating system. So last week we talked about more about the memory management. So we introduced the idea about paging, segmentation. So it's a more common. So what's the difference between paging and segmentation? Anybody still remember? Is what
Paging is the process. You separate the process, right?
one is the RAM assign, one is the process. So which one is belongs to which one? Paging, segmentation.
I think paging is like, I think it's a management method.
Yes, okay. For the memory, because when we learn about for the static and then static allocation, like dynamic, and then we try to assign a process, right? And then last time we did is using different approach, like first fit, next, right? The worst, next, right? Okay, what's the problem? What's the problem when even though we try to use different methods, but what's the problem issue? We have one keyword like we talk about. Okay, what's the keyword like we talking about when we like try to allocate all those processes to the memory? We always cause the problem. So what's that problem? Yes, fragmentation, because we cannot utilize the memory better, right? Because like when we if a dynamic, I give you a, if you remember in the exercise, I give you what 1 gigabyte, and then when we have processing comes in and then they leave, computed new, then we do have like certain block is like we have internal fragmentation. That means like within that memory block, we only have like maximum or less than that memory, right? And then we have external fragmentation, like we have some process cannot fit into those like blocks, right? Okay, we have this problem. Then we will start to think, how can we utilize the resource better? And we introduce like paging segmentation. Okay. So paging is the memory management scheme that eliminates the need of a continuous allocation of physical memory. So which is to the memory. One's for the so one is for the process, one is for the main memory. So why not which one is for the main memory? Paging, yes. So paging is like this one. We need like logical when we talk about the paging, if you remember when we do paging, we need to create something. So what's that one? We need to have a table. Paging table. Okay, we need to create a table. So we remember last time we talked about how many bits, right? Okay, so here's way. So we call the logical address space and physical address space. And the physical address space is referring to the actual location in the main memory. So where we going to put. And then logical is that we can put in like maybe for this process, it's going to a certain location, but we need to like adding it. And we have the pages and called the page frame. So those are we created. So what we need, we can simplify the memory allocation and eliminate the external fragmentation. Is a benefit, and then it's allows the easier process to load and swap out. Okay. But what's this disadvantage? We still have disadvantage. Like you see, the fragmentation still exists for internal, but for some unused memory within the page, it's still going to be possible. And also we have the overhead maintaining the page table because we need to keep on updating. Okay, process come in, then we need to update our table and then update the the location. Okay, referring the getting offset. So we have the page default overhead. So it's all going to happen. And then for the page table structure, so we're mapping the logical page to a physical frame. Okay, and the page number, frame number, value bit, and then protection bit. So in more details, in the lecture you only see we have the page table, so with the block and then the offset and adding them together, and that's it. Way. Last time, if you see the lecture 8. Yeah, okay. Next one is 3, right here. So we can multiple process page table, and then we try to adding is like if we have a 16 bit the logical address. So we have a 6 bit is to save the page number, right? And then 10 bit is the offset. So we have the 6 bit, we refer to the page table. So those page table, their location we add with the offset. So will be like 6 plus 10 and then combine together. So it become the actual physical address. Okay. Go back. But for details, we do have more than that, the frame number, availability, and protect. But just like make it simple. But this one just for extra information, so you knowing. Okay. So when we need to replace it, so we have a page replacement algorithm. So when the page first occurs, there must be decide which page to remove. Some common algorithm you need to know. We have the LRU, the least recently used, or the first in first out, or the optimal page replacement. So there's a different algorithm you're going to apply. If I telling you I have a logical address like is 8 kilobytes, and then we have page size like 4 kilobytes, and we need to create a page table for this address space. Then how can we create? So I will upload this one. So we have the page table creation. Okay, so let me enlarge it. First, we need to know, okay, how many pages we need to create. So right here, if I telling you we have the logical address space is 8 kilobyte, and each page size is 4 kilobytes, right? And first step, we need to just divide it. So how many pages we need? 2, because 8 divided by 4. Okay, so we need to have 2 pages. And then we have pages. We need to getting what's the frame size. Okay, how many frame we need to create. So for the frame, so if we have the physical memory address is 8 kilobytes, and then the page size is 4 kilobytes, and we just have the same frame size is 4 kilobytes. So number of frame is like the physical memory divided by the frame size will be 4 kilobytes, so we just need 2 frames. So you see it's the same. So we have 2 pages and 2 frames. And the logical page number, we always start with the 0, okay? 0 and 1, and then the frame number 0 and 1. when we move on, so we have like mapping the logical address to the physical address. Okay, so right here we have consist if the 3 bits let's say like if if we have the 3 bits, then because we have the total 8 kilobytes, so 2 to the power 3. So the 3 bits is for the page number, and then we have the offset is the 12 bit. So 2 to the power 12 is 4096. So this will cover enough for the 4 kilobytes page size. Okay. So here's you need to check is the different like pages and then the offset. Okay. Well, the 4 kilobytes is the frame size, like how big is of the frame. So you need to getting this number. So when you start to match it, so we get a start with the beginning. So the offset is like the logical page is 0, and then our offset is 0. So it's the first one, page 1, pointing to frame 1, 0. So we have because each of it like 4096. Then we start with the 0. Okay. So what's the next one? So we're adding the next offset, right? Offset with 4096. So we'll start with like 4096 right here. And then keep moving on. So because like we have 2 frames, right? 2, and the next one, we need to move on the from the frame. So when now we're moving, so this time will be times 1. So 4096. And then because it's just like offset is 0, so we will start with from here. So the logic is times right here. And will be, that's it. Of course, like you can. And if I give you after this, I will give you a question you can calculate just like for your exercise, just follow these steps for calculate. If I ask you, okay, if I have a logical address space, the page size, then what's the how many pages we're going to create? Then you can just divide it, and then what's the number of frame? Just like refer to the equation, and then what's the mapping logical pages? So in this the logical address, so what the page number and offset number. So make sure they are able to cover how many size of page size. Okay. So just need to calculate. And then let's go back, keep going. After this, then we will like calculate the page, and the frame we will have called the page force. Okay. So those like maybe we have a certain strengths, and then we have a force. If I tell you we have 2 algorithms using the LRU, or like maybe the first in first out, then which one? So if we are using 3 things, then how can we calculate? So here are the examples right here. Okay. What you need to do is just like create a table. So I'm telling we have 3 themes right now, and we have if I give you the reference string right here, so 701 203 04 23. Okay, in the initial steps, you can just create the table, so you can adding every time to step 1. So first I will get a 7 because we have 3 themes, right? So frame right here. So I just assign to the first frame, and then second comes in 0. So I put it in the second frame 2, and 1 comes in, and then put it frame 3. So right now, here's where we still okay. Yes, okay. We are putting in, and then if we get the 4th one, number 2, which one is the least used? LRU. Yeah, the first one. Okay. So I'm actually doing this. The least used right now is 2. Because right now the frame 1 is least used, so I will remove 7 and replace 2. So do we have a page force? Yes, we do. Same, we replace 7. Okay. If we didn't replace anything, you just leave it empty. But we do. Yes, we do. Okay. And then right now 0 comes in. what's the, based on the LRU, what's the next LRU? So why is no, and then anybody? Oh yeah, you overlap. Can you repeat? Yeah. Could you repeat one more time? Is in there. Okay, and then also why we are using frame 2? It's over there. But because we are getting input 0, why I'm not like putting in other frame? Just based on, because we are using least using use, and then what's the least using use frame? In current stage, which one is the least using? It's a 2, yes. Why is 2? Yes, just a second. So because when it step 5, so because like 1, 2, 3, right? Why now we replace 1? So what's the least would be the frame 2? Okay, so that's why we look at frame 2, and then because we need to replace, so we already have if we need to work on the frame 2 with the reference 0, but it's the same value, then we do not need to replace it. So we do have it. It's already over there. Then we don't have to change it. So no page false. So we're not replacing anything. Okay, then we move on to step 6. Okay, so we are inputting 3. Okay, 3, and based on the LRU, so what's the frame we are using right now? Frame 3, right? So 3. Okay, and then next, and then we will replace 1. So we do have a page false. So we put in yes, and then keep going 0. How about 0? Yes, over there. So we don't need to do anything. And after 2, then we'll move on to 4. So when what's the LRU? 1, and then we have 4, and then check it and push it in. And 2 comes in again, 2. The LRU, current LRU. 2, yes, go on, and then page 2, and yes, we page 0, and then last one 3. What's the current LRU? 3, right? But 3, but also because 3 is already exists, so we're not doing anything. So when we based on the algorithm I'm asking, maybe like in the meanwhile you have to keep on checking what's the kind of like which one you're pointing to. Okay, which frame recording. Okay, first in, first out, or LRU. So after you check, then what's the final page false? Okay, so you need to tell, okay, so you just count how many of them, and then you can paste it. Okay. Good question. So guess. Well, if let's say right here, well, like when we replace that, at least we're counting right here 1, 2, 3, 4, right? At least 4. Yeah. But why we are making 6? Or if I make the typo. Okay, so okay, so just like we count what you have put the yes, then it's okay. Okay, so you can't say for 7. Okay. Okay, and we can have like optimal like page replacement, and then or the possible like to reduce the page false. Maybe we can say optimal is like replace the page with no use for the longest period of a future. Or like we can increase number of frame, then we can reduce the frame, but we need to increase when we increase number of frames, what's the problem? We do have more page, that means we need to increase the size of it. That means the hardware, right? Okay. And then locality reference. So if we write a program with like good locality the references, then maybe we can access less of the pages. It's possible, or we can like create some cache to reduce the access. And also like we can modify the workload profile application. Okay, and is an example right here, and then we talk about right here. So it's the same. We still in the paging. Even we introduce paging, we still possible have the so the fermentation. So we all know the term internal, external. So we have the memory. Like for internal, they are allocate for the page is not used. Okay, still because we try to allocate a page, so it's the page is still using a physical address, right? So it's still possible the size of the process when we talk about the segmentation. It's still possible that when we assign the certain segment, okay, small a part of the process to the page, is still maybe smaller than that page size. That means we still have an internal fermentation. So this concept you just need to remember. And then for external, maybe not applicable in the pre paging, and also mitigations like we need to use the larger like page size. Okay, so for the segmentation, so it's like also another the memory manage tennis. So we will divide the process into segments. Okay, so we know just like distinguish though they are all based on what the logical division. So we can base on the function array. So when we create all this, so they will create into different segments. Okay. So those segments represent the logical unit of a program. Advantage of the segmentation, so they facilitate sharing and protect the code and data. So most of the time we will try to split the code and data in different segments. Also, we allows the dynamic size of the segments, or we can easier to handle the growing data structure. So but we do have some disadvantage. So for the segmentation, we cause the external fragmentation. So we do have the internal, also this time is the external fermentation, and it's more like complex when we need to manage both sides of segments. Because the segments we know, even like when the process come in, when we allocate, so process, they do have different sides, right? Right now we try to break down like change to segment, using segmentation. But for segments, because we will try to break down functions, verbal, the arrays, that means like all those still have a different size. That means we still need to manage the the size of segments. So also we need to create the segmentation. Like then we need to create the tables for segments. Okay. So for those like including the segment numbers, base, limit, and then protection bits, that's all included. And then we'll show you the samples of segmentation. We do have an exercise. Okay, but before moving, I will cover all these. Okay, so let's say I have a program. That means the process comes in. I have a code is 10 kilobytes. So we have the data and stack. If you still remember the PCB, inside the PCB of the code data we have stack, right? So I giving the different size. So this one I already gave you like 10 kilobytes, 8 kilobytes, and stack like 4 kilobytes. And when we create a segmentation table with the base and limit, now how can we do the segmentation? So you can look at right here. Okay. Okay. So right here we have some columns we need to know. Okay, we have the segmentation, give a name, what's the segmentation, and then the base. So a starting address in the physical memory. Okay, so we're going to start and then limit the size of that segment. Okay. And if we need to calculate the base address, how can we do that? So first, like always, in the memory, like sequentially we're pasting, so we'll put the address start with the 0. So the 0, the base like segment. But if you look at the PCB or the structure, we always like top to bottom, so always start from the code. So base with the 0 address, and then when we start the data segment, it's 10 kilobyte. That was it. What is 10 kilobyte or 8 kilobytes? And then next for the stack segment is 18 kilobyte. How can we get this number? Yeah, pretty straightforward. Okay. So it's not complicated. So because the size of the code is 10 kilobyte, we always start from 0, right? Okay. For this segment table, we always have start from 0. So 0 and then limit. That means the size of it. So will be 10. So because it's continuous memory location, so you're setting. So from 0 to 10. So what's the next data? It's following 10. So it's just 10. And then what's the size of it? So the limit is 8 kilobytes, so it's 8. Show you plus 8. So that's why stack is start from 18. Okay. And then stack we have a limit. So I already given you the segment stack 4 kilobyte. Okay. If I ask any question, you're always able to see the structure format like this one, because you cannot like guess or like one. So when I ask you to calculate the address, you can do it. So here can like we try to set up the limits. You will see right here, and then the final segmentation table will look like in this format. And we do have some difference with the paging. So we would divide the memory in the various like segments based on the logical. So you'll see right here. And then for paging, we will have a fixed size of the pages. Okay, we create the frame. So those like they do not consider the logical structure of the program. But for the segmentation, we do. Okay. And then size for the segmentation, can be like obviously in the size, but for the page, same size. And then for the address segmentation, we use the segment numbers and then the offset. So within that segments for the address. Okay. So it means that the logical address consists of the segments selector and then of the offset. And for paging, we have the page number and then the offset is within that page for the address. Okay. And for the memory management side, for segmentation, we can allow like easy to manage the logical, logically related to the data and code. And for paging is like just like simplify the allocation and management by the fixed size of page. Okay. That's how it looks like. So when we access in the memory, if I give you the segment numbers 1 offset 5, then how can we determine the physical address? Then we need to knowing. And right now all the system like so we are like can combine both technique to get the advantage. So it's pretty common for our system running right now, paging and segmentation. So it can be provide better like use of the memory and also for the management. So we can look at it more details like for some system when we combine. So how can we get it? Then let's move on to give you some exercise. Let's see. We will start with the paging table. So this time I will change the number. So for you to do some exercise. What they saying? Okay, given. Let me put it the exercise. Yeah, because like for all these questions, you will see like pretty similar coming for the quiz. So like soon we have a quiz, also the assignment. So we're doing all this calculation. So including the last lab, like all those best fit, and also for the calculation. So let me create the assignment and give you. Let me change it. Still working in class. Class. Paging. Look at the green. Paging, and you also need to calculate the page font. So I'll give you this one first. So when now I change it to slightly bigger. If let's say I change it, I will keep the logical address to 32. And then page size, like this time I'm doing 2. And then you can just calculate. And also I post another one is the page force. Okay. So this time I change it. Maybe I'm using 4 frames and then giving a string. Okay. So there are 2 different exercises, so you can try to follow a step. So it will be pretty straightforward. So you just need to for the calculation to calculate the page size. So you need to get the page number of page. Oh, still hidden. Okay, yes. Okay. Okay. Visible. So you can download. You should be able to see the question. Okay. And the examples on the detail, yes. So you will find all those example on the called the calculation of the page force, and then we have the page table creation example. So will be these 2. Okay, so you can try to do that. If let me hit the left button. Left. Yeah, when you calculating, actually, when you, yeah, I heard you mention about the number of pages, right? So we do like mention in the discussion. So if we have the page size like this, actually it's not the ideal case. Okay, so when you do a Yep. We also need to have so you need to do step 1, 2, 3, 4. You need to, for the current paging, you need to give me all the step 1, show me the page number page, what's the frame, also step 3, create a page label. And then later just tell me what's the number of bits for the page number and then offset. Just checking out. Well, understand. Actually, all these numbers refer to the size. Well, this one is one size. You will actually see this. Yes, it's yeah, for this. Is it possible? I say the same. I think it's the same with 8. It's physical 8. So for I give you 32. So here, yes, will be 32. Okay. So it will say now. Okay. Yeah. Yeah. I give you one is 32. So we need to change it to 32. It's a formula one. That's not giving you the logical. Yes. Yes, no separation and then we put that for you. Yes. Double vision separation for them, and then later in assignment, I will include, I maybe I change the unit, or I will add in the other algorithm like first in, first out, or others. So you can practice like different type of. See. The question. One more time. Let me set the date. Next week. Second half. So you see, just remember that those, okay, we all now we're using page 4, right? So we're asking at page 4, so if you look at step 5. Okay, so will we have a zero overlay? So we exist, so are we going to replace it? Because it already exists there, so we can be very flexible, so we don't have to replace it, okay? And then how about ARP? Just the extra information, because when you need to assign. I think if for the calculation, you just follow the step that you can get. So, example is 4 kilobytes. So 4 kilobytes. So 4 times. So 4 kilobytes would be 4 kilobytes 4 times. 10 to the 4. So you know when it's based on this, so 4 times. Okay, if you know familiar, so 4 kilobytes. So you compare it, so 4 times 10 to the 4. Because the same design for 1 unit, so if I from kilobyte up to 10 megabytes, it becomes 10 to the 4. So for this one, if I times it is 1496. When you keep the size, so basically because we are in a binary world, so most time when we in some case we always use the power of 2. Okay, so this one most of the number you see is either 2, 4, 8, 16, 32, but so it's for instance. So right here, with for 4 kilobytes will be total number is 1496. Then for the bit numbers, yes, yeah, so this one, so it's the same. And then if I use the bit into the 12, will be enough for, will be cover 1496. Yes, yeah, you just like to and then you just need to find the power of it, so you know how many bits it will be enough. Okay. Okay. Yeah. So, big program is using pages, 6 pages and 4 pages.
So then. That's.
Yeah, yes. Yeah, it's represent. Go check your page number. Because so some of you maybe ask the question about the page number bit and the offset bit. So you just need to check it for the page, and then because we have like 8 kilobit, and then you just like convert it. Is the everything just based on the 2 because in binary number. So we just use the base is 2, and then just check the power of it. Okay, so to the power of 3 will be 8. So you need to check the, I give you the logical address space with 32, right? So to the power something equals 32. It's pretty straightforward. And then you ask like, then how about the offset? So offset, because like every byte. So how about this one? How about anybody finish this one? Okay. Okay. So why is 2 to the power 12? Where can we get the 1496? Do you have a question why? How can we get? How does it come from? You answer that. So you can. How about others? Guess. Why? No idea. Okay, actually it's right here. So we also cover 4 KB. Then why 4 KB is changed to 1496? Because there's the offset. So offsets represent each single, just like imagine or there's a single item you're saving it. So I convert the KB, right? K in binary row is 1024. So it's 4 times 1024. So total will be 1496. So here's the offset. If we are talking something else in the decimal world, then it will be 1000. But in the binary world, it will be 1024. So when I give a number, so in the exercise, it should be 2 kilobyte. So 2 kilobyte times 1024, 248, and then what's the 2 to the power something equals to? Yeah, of course you can use calculator to check it. But actually, you can see right here, somewhere is usually -1 is okay. Yeah. Okay, so start with the beginning for the pages. So we will refer to the reverse frame. So always the 0. So because for 1496 is the same. So every of the 2048. The first one always begin with the 0. So it's easy. And then what's the next one? Next one is how many so right here we have 2 pages. Okay, so that was, and then but we have 2 frames. So the second one 0 times 1496 and add the offset. I think this one is done, and then we'll move to the next page. But so this one, since it's page 1 offset 0, yes, this one be page 1 offset 1, yes. And then the next one, page 2 offset 0. Yeah, it's still going. Yes. Oh, yeah. Okay. But this one just like make it short. Yeah, but you are not required to have this one. We're not. You do not have to stop here. Yeah, you can stop over there. It's okay. Okay. Because for the mapping, I'm just telling you like how it's going. So but for your answer assignment, you okay. If you are confusing, this one is just letting you know like the example mapping, just telling all the details. Okay, so you are not required. So you can stop by right here. Just tell me the page number and offset. What's the bits we're going to use?
Just telling you how many bits.
Yes, and that's it. And you can stop it because it takes 2 minutes. If you have 32, it takes forever. You're not going to, you're not required to do that. Okay, so even the assignment question, everything, just stop by right here. It's okay. So this one I just want to showing you. Okay, so how the actually mapping is doing. So when you have the like first page 1, page 2, and then how can you calculate with the like the frame? Okay. If you're completed this part, then you can move on to for the page calculation. If a student taking online, if you have any question, feel free to ask. If no, or you're working on it, or you already submitted it, then you're feel free to leave. Okay. And that's if you're working on the page first, you will see two ones come together, and then remember refer to the example on the page first. If I have two zeros, what do we do? And also when because we are using the arrow view, so sometimes when every time, and even we miss, but you need to remember what's the arrow view, which one we are pointing to. Okay. I think most of you already finished, so I just put it look like this. So would be based on the logic of space, these were the page size. So why not use what's the logical address? And the page size is 2 kilobytes. So total how many pages will and so 16 pages. What's the frame actually frame size? So we just actually a physical so what's the most of the time we just if I need to carry on for the assignment maybe I will change because I think I will change the physical then you need to change the purpose one. You just follow just I will just using the same. It's easy if it is same size for the logical and physical. So it's and so it's supposed to be match the same. If once you have a different frame size and the offer same, you will see the differences. We want to get them matched, so it will be the same. Okay. Okay, I'm happy. I just it's an example. I just wanted to show the offset and it's okay because it's the time. If you're 16 and then you're probably says you so much. 16. So that's what I'm working on. This one is using it as online. Okay. Okay, actually, yes, that's not the same thing. Yes. For this one, it's just like keyboard replace number. If I giving you even the physical address, not the same, is more. Yeah, but at least you need to know why. You know, it's an equation. You're like in the equation, telling you which one is the which one. So don't just like copying from that.
So I don't think it was that.
Well, you have to do this, you don't do this. Which you do have to calculate. Still using 14 because. So this is 32. Yeah. But if you look at my example, it's like 4 kilobyte, I'll be that by two, so because always it's like a little time sheet. Still for 4 kilobytes. So the total work was like total of 4 kilobytes. So then I actually minus by 2, then it would be more 2 kilobytes. Yeah. So that's why when you do it, it's very easy. 12 minus 12, so it will be 11. Yes. So letting you know, later we have the assignment and quiz is similar to all this question. Okay. Yep, sure. So if you have no other question, you're feel free to leave and then. Because we already exist at the level. Yes, I will give the assignment later, so about all this exercise. So including the like best speed, next speed, so I send you like
maybe just one question, try to fit all those questions, and also the calculating, but this one may be I'll including like maybe the physical. If you look at the question I gave you, so what are possible advantages? Maybe the physical address is not the same as how they change. But also I will try to give you the assignment and then go through some questions. So prepare for it, and then I will create a quiz. So including all these like questions. Okay. I'm available after Thursday, so I will give you. I'll give you a longer time because I want to give you more exercise like this. Okay. Well, maybe I mentioned about the first in, first out, maybe you have no idea, maybe you need to. I try to let you to do the assignment, so you have like better idea, also I'll go through. Okay. That those are okay. And it will be the same, so on Thursday, enjoy your Halloween, so I switch it to online, so you can join it. So also, it's mainly theory, so for we'll start our new chapter, is about a VM, but mainly it's just theory, no exercise. But of course, I will prepare like for maybe next week, I will give you some exercise about the VM, so we can practice for some like calculation. Okay. Just online, maybe, yeah.
Only online on Thursday.
Yeah, only online.
Okay. For all three?
Yeah.
So.
Or do you want to, just asking, because because I have a few classes, depends on this afternoon, if you want to everything, do it for
But did we establish for cyber and web programming?
Cyber with online, but thinking, you know that also. Have fun on well, because you know my first day is mainly lecture things, so you can refer to the online or like something. Just go through the PowerPoint, yeah. Okay. Okay, and then I will end the sharing. You can keep on working. If you have a question, you can keep a question. I will give you more practice and okay, give me. Okay. So also I'll give you more like practice like for this like calculation things. Okay. I will stop right here. Let me see if some question. Okay, no question. Then I'll stop right here. The online sharing. Thank you.